Hello, everyone. Today we are solving two tasks from the data analysis exam, which is matching visualizations and interpreting a regression model. So let's start. So part one, you can see we are going to match the visualization. So here's the task. We need to match each data characteristics with the correct visualization type. So let me explain the four visualization types. First is pie chart. It shows a part of a whole based for categorical data like percentage, and another one is bar chart. So it compares discrete categories. Each bar is a separate category with space between bars. And the third one is histogram, shows distribution of continuous numerical data. And it shows the bars which touch each other. So you can see here, this is a histogram, just data, and here is this one is your bar chart, which is having some separation in between. And then you can see a box plot which shows the statistical summary, which is here, statistical summary, median, quartiles, outliers for continuous data. So now let's match each row. So we'll be going to do distribution of Titanic ticket prices. So Titanic ticket price is continuous numerical data. So we want to see the spread, median, quartile, and outliers. Box plot is perfect for this. So we'll be using a box plot here. Box plot, and then another one is you have numeric a number of satellites for each Titanic passengers. So in this you can have 0, 1, 2, 3 satellites, which is the numerical value, but not 2.5, which is decimal. So we are comparing frequencies, not frequencies of distinct categories. So this can be a bar chart. So we'll be putting it this one into a bar chart. And the third one, distribution of passenger ages. So here we will be using a histogram. And I can tell you because we'll be using a continuous numerical data, so we want to see how ages are spread across ranges. So we'll be using histogram here. Sorry, here I need to remove first histogram. And the fourth one, I will be using remaining pie chart, which is a because it has only two categories. So, uh, how many Titanic survived and how many were dead. So we'll be using a pie chart to differentiate between uh, dead and survived categories. Pie chart. Okay, and after this, we are going to do question three, which is correlate the variable. So in this, we are going to correlate, which is a grape variety grape. So in question three, we'll be using we'll be doing grape variety sections, which is a column. Here it is a name, so it's like a merlot, cabernet, and pinot kind of name. So I'm giving an example. So these categories are without any order, so we'll be putting it into a categorical nominal. So this one will go here. And in the family income, which is a high, medium, low, here we'll put categorical ordinal because they have a clear order like low, medium, high. So here we'll put here. And then in human height, so let's say height can be 170 centimeter, and also in decimal form 170.5 centimeter. So it can take any value in a range. So this is a continuous. So we'll be putting quantitative continuous. So quantitative continuous here. Net quantitative continuous. Number of children in the family. So number of children a family can have 0, 1, 2, 3 children, but not 2.5. So this is a whole numbers. So this is discrete. So we'll be taking as a quantitative discrete. Quantitative discrete. Okay. And here discrete. And the end, we have presence of VK profile, which is social network. And only two options would be like yes or no. So this is a binary. So we'll be using categorical, nominal binary data type, categorical, nominal, binary. So this is the same. So there's no need to change. Here and the question 4, we'll be doing a measure of central tendency. So here the question is about what measures of central tendency should be used. So here we'll be analyzing it using educational level, which is a categorical ordinal. The number will be 1, 2, 3, 4, and represents order categories. So, but here's the critical point: the difference between category is not equal. So, the jump from secondary school to bachelor's to is not the same as the from the master's to the postgraduate. So, these are just labels. So here, arithmetic mean is calculating the average of 1, 2, 3, 4 gives 2.5. But what does it actually means? Is like if you the medium if you jump from a secondary school to a bachelor's and is not the same as the master's to postgraduate, so we can try to differentiate. So the medium, the other part which is a median is a middle value for order data. So this could work, but the only four categories, the medium isn't very meaningful, so not the best choice. So variance is like this measures spread and not central tendency, incorrect. Mode is the most frequency occurring tendency, which will be value, which will be this perfect for categorical data. So it tells us which education level is most common. So the answer for this question would be the mode. Mode is the most for categorical data. We'll be using mode. The mean only makes sense for truly numerical data where differences between values are meaningful. And in question 5, we are going to use. So in the question 5, we'll be looking at the graph. So in the population 1 graph, you can see here, it looks more symmetric, and median is like more, mean is more equal to median. So more symmetric look is there. In population 2, it's look like right skewed. So the tail extends to the right, which is mean tail extends to the right, which is mean is less than median. So mean is greater than median. In population 3, left squid. So in population 3, the left is little squid. So the tail extends to the left, mean is less than median. And in the fourth, by model or uniform. So it's hard to say. This is like by model and it's inform. So it's very hard to say what we can do it. So since we need mean, which is greater than median, so we are looking for right squid distribution. So the answer for question 5 would be population 2, which is this one. And for another question 6. So in question 6, the left edge of the box, which is a Q1 25 percentile, it shows 593. And here the middle line median 50th percentile, so 725. And on the right edge of the box, which is Q3 75 percentile, it shows 736. So the whisker shows the range, which is a interquartile range, and which is we'll be using a formula Q3 minus Q1, which will be 736 minus 594, which is 143. Now in option 1, which we have 25% of this, more than 593 people visit, and the weight is like 593 is Q1. So this means 75% of days have more than 593 visitors and 25% have fewer than 593. So the statement is incorrect. Option 2 also is incorrect because this means 50% of days have more than 725 visitors, not 25%. Option 3 is also incorrect, which is the average mean is not shown in a box plot. So the box plot shows the median, not the mean. So 593 is Q1, not the average. Option 4, the interquartile range is 143, which is that is exactly correct. So the interquartile range is 143, and the rule is that a box plot shows quartiles, not the mean. So in when Q1 is 25th percentile, median is 50th percentile, and Q3 is 75 percentile. So we use a formula Q3 minus Q1. All right. So now in question 8. Question 8. There's no question 7. Okay, so question 8. So in question 8, the answer would be A because let's say we assume A shows the clearest downward trend. So for the stronger inverse correlation, we want the plot where points from the clearest downward line. So without seeing the actual graph, so we can see the A is more in the downward line. That's why the answer will be inverse correlations, which will be a negative relationship, downward slope, and stronger correlation it will be equal to tighter clustering of points around the line. In question 9, we found a correlation of 0.81 between job satisfaction and productivity. So the answer would be option 3 in question 9 because in question 9 the correlation is not equal to causation. The correlation of 0.81 means there is a strong relationship, but we can say which variable causes the other which variable causes the other relationships. And question 10 is about regression terminology. So in this we will be using, so the price is what we are predicting, so the target and dependent variable is already given, and the answer is uh, we need to each apartment in one data point it's an observation, so we can match it final, which is price would be target variable. It goes here into a target variable. Mm, W0 will be free coefficient coefficient with, and here W1 will be coefficient of independent variables, which will be this one, and this will remain as a predictor because distance to metro is predictor and we are predicting it, and independent variable, and apartment will be coefficient of independent variable, but it will be here observation because we are observing the apartment with okay, so the target is what we predict, the predictor is what we use C, so W0 is the intercept, W1 is the slope. So in question 11 we will be using our model error analysis, which is here. So in this analysis at 0 hours, you can see that the blue line is far from the red point, so it's a large error. At 2 hours, the blue line is close to the red point, which is small error. And at 4 hours, some distance between prediction and actual. So now let's check the error. So error for 2 hours is less than 0 hours. So looking at the graph at 0 hours, the prediction is significantly off. You can see here. And the prediction is very close to actual. The statement is also correct. But if you see in the option 2, so option 1 is correct option and option 2 is incorrect because without exact data values we can't calculate this precisely. In option 4, option 3 also we cannot calculate this data because there's an uncertain data flow into the root mean square error. And option 4, this would mean perfect prediction. The graph shows deviation, so error is not 0. So this is also incorrect. So the answer is option 1 because error is equal to actual minus predicted. So smaller distance between red point and blue line is smaller error. So you can see the more smaller the error is, the better the prediction is. So the question 12, which is the regression formula, which is at the end here. We have the formula salary, which is 30,000, 20,000, 10,000, 20,000, and 10,000. So, and the question is that what salary is predicted when all features are 0. So step 1, set all features to 0. We set it all. And then step 2, we'll be using substitute into formula. We'll be using 30,000 plus 0 minus 0 plus 0 plus 0. So we are trying to multiply every formula with 0, which is A, B, C, D. And then we'll be using checkpoints, and the answer would be 30,000 rubles. So the intercept is 30,000 ruble. This is the answer. So this one is the answer. 30,000 ruble is predicted if the job description is not contain the word senior graduate programming Moscow salary starting. So answer is 30. The intercept 30,000 is predicted when all predictors are zero. Okay, so this was the end. So today we covered all the key concepts. So we covered data types, nominal, ordinal, discrete, continuous, binary. We covered central tendencies, which we use more for categorical data. Then we covered the distribution shape, which is mean is greater than median, box plot, correlations, causations, and regressions. Good luck for your learnings, and I hope you practice yourself at home. Thank you.